Good morning, students. I hope you all are doing very good and utilizing your time. So, today I am here with the second chapter of physics named electric potential and capacitance. So, students, the first topic of this chapter is electric potential difference. As you know, the electric potential difference between any 2 points is the work done on bringing a unit charge from one point to another point. So you can see here I have pointed 2 points, point A and point B. Okay, a charge Q naught is kept at point B. Suppose it is of 1 coulomb. So work done on bringing this unit charge from the point B to point A is known as potential difference between these 2 points. Okay, so potential difference between these 2 points can be defined as work done on unit charge for moving it from point B to point A. Okay, it was all about the definition. Now we can represent it as a VA minus VB is equal to work done on unit charge. Note down one thing, students. We have written here VA minus VB. We are not writing VB minus VA because the final position is at A and the initial position is B. And we always write potential at final position minus potential at initial position. So VA minus VB is equal to work done on unit charge. Now see what happens if this charge is not unit charge. So for charge Q naught, work done is W, then potential difference V is equal to VA minus VB is equal to WB to A. B to A means we are bringing the charge from point B to point A. WB to A upon Q naught. Okay, now if the distance between point B to A is very small, so for a small distance the potential difference between these 2 points must be very small, and work done on bringing the charge from one point to another will also be very small. So we can write here dV is equal to dW upon Q naught. स्मॉल डिस्टेंसेस के लिए जो पोटेंशियल डिफरेंस होगा वो भी बहुत कम वैल्यू होगी उसकी, सो हम उसकी जगह क्या लिख सकते हैं डी और वर्क डन की जगह डब्ल्यू लिख सकते हैं. सो दिस इज द फंडामेंटल फॉर्मूला ऑफ दिस चैप्टर. ओके, नाउ you can see I have mentioned below it is a scalar quantity, but students, how do we come to know this? By this formula, if this Q naught is of 1 coulomb, then this potential difference will be equal to the work done. And as we already know, work is a scalar quantity, so this potential difference is also a scalar quantity. Okay, now the next term in the series is unit of potential difference. So the unit of potential difference can be determined by the formula of potential difference. As we know, VA minus VB is equal to W upon Q. So unit of work is joule and unit of charge is coulomb. So the unit of potential difference can be written as joule per coulomb. We also write volt. It is in the honor of the scientist Volta, who did very great works in the field of electricity. So it is the another unit of potential difference. Now the another thing is 1 volt. Children, by this formula you can see here, if this work done is 1 joule and this charge is 1 coulomb, then this potential difference will be 1 volt. So we are defining it here. When 1 joule work is done on bringing a charge of 1 coulomb from one point to another, then potential difference between these points is 1 volt. So many times it is asked that define 1 volt. So we can define like this. Now the next important term in the series is dimension of electric potential difference. So by this formula, V is equal to Q upon W upon Q, we can calculate the dimension of electric potential. So as we know, the dimension of work is ml2 t minus 2, dimension of charge is at. By solving this, we get ml2 t minus 3 a minus 1. This is the dimension of electric potential difference. Okay, so this was all about the electric potential difference. Now the next term is potential difference and electric field. Means now we are determining the relation between potential difference and electric field, because potential difference is produced due to electric field, so there must be a relation between potential difference and electric field. Let's see what is that relation. So here it is an electric field, and in this field there are 2 points, point A and point B. A charge Q is kept at point B. So in presence of electric field, this charge Q will experience an electrostatic force which is equal to Q into E. Okay, and by experiencing this force, this Q will tend to move towards the point A. Okay, the direction of electric field is towards right, so the direction of this force is also in the direction of electric field. Okay, see, note down one important thing here. The direction of force is this and charge is moving towards left, so direction of displacement is towards left side. Okay, now see, at point B, force on charge Q is F is equal to Q into E, as we have discussed it before. Okay, now potential difference, what will be it? VA minus VB is equal to W B2A upon Q. Okay, now this work done is equal to F force into displacement into cos theta, Fs cos theta upon Q. Okay, now this theta is equal to 180 degree. How? Direction of force is this and direction of displacement is this. So angle between them is 180 degree. That's why we have taken theta is equal to 180 degree. Put the value of force F is equal to Q into E in this expression. So it will be Q into E into dr into value of cos 180 degree is minus 1. We are cancelling Q by Q, so we get dV is equal to minus E dr. So we can write the expression for the electric field. E is equal to minus dV upon dr. Okay, this is the relation between potential difference and electric field. Okay, now one small change in this expression. If we shift the charge in this manner, okay, in the previous diagram we were shifting the charge like this, now we are shifting it towards this direction. Now what will happen? See, the angle between this and this is theta. Okay, so this angle is also theta, this angle is also theta. This divides into two components, this and this. So on joining this type of triangle is formed. Okay, now we come to displacement. Should we take the displacement dr as before और dr cos theta? हमें dr लेना चाहिए डिस्प्लेसमेंट या dr cos theta? Now see, the displacement in the direction of force, the direction of force is this, और force की direction में displacement ये हुआ है. Okay, so we will take displacement this, not this. That's why we have used Pythagoras theorem in this triangle, and by that theorem or by those trigonometric ratios we got the value, or we got the displacement dr cos theta. Now in the place of displacement in the expression here, you can see here in this place, at the place of dr we will put here dr cos theta. Okay, so by putting this we get the final expression e cos theta is equal to minus dv upon dr. Okay, so these are two formulas which tell about the relation between electric field and potential difference. Now see, I have written one thing here. Potential is decreasing. You can see the minus sign here. Minus sign means potential is decreasing, and this E is of positive sign means in the direction of electric field the potential difference is decreasing. Suppose this is the direction of electric field, so at this point if potential difference is, if potential is 100 volts, so at this point it will be 90, at this point it will be 80, and it will going on decreasing in the direction of electric field. Okay, this minus sign represents this. Next thing is another unit of electric field. By this formula we will derive that unit. Okay, so electric field E is equal to minus dV over dr, we got there. So the unit of potential difference is volt and unit of displacement is meter, so it is volt per meter. Okay, now if one of them, formula is E is equal to minus dV over dr, so if one of these value is not given and two values are given, दो values अगर दी हुई हैं एक value नहीं दी है तो तीसरी value आप easily find कर सकते हैं. See, like this example, electric field E is given, it is 20 volt per meter and displacement is 10 meter. We have to calculate the potential difference. So from this formula dV is equals to EdR. So EdR, we will put these values 20 into 10, so 200 volt is the potential difference. So children, we will meet in the next video with the next topics. Hope you will complete these topics only. So meet you in the next video.